Alright, so this is just an example of some graphing transformations using our general sine curve. So if we're given this equation, we need to first identify what transformations we have happening. And so we have the -4 is going to be our vertical shift, our 2 is going to deal with our amplitude, the 4 inside the parentheses is affecting our period, and finally the -20 with the angle is going to be our phase shift. So if we start by figuring out where a sinusoidal axis goes. So instead of 0, it's going to be going down at -4. So we plot that horizontal line. And then my amplitude says I'm going to go up to and down to from that axis. And so I have now my bounds for my sine curve, my upper-lower bounds and my sinusoidal axis in the middle. And the 20 is 20 to the right. So that's going to be my starting point. Now I need to determine my period, so I use the fact that the period is 1 over my b value, which in this case is 4, times a full period, which is 360, which gives me 90 degrees. So if I go 20 plus 90 degrees, that gets me to 110. So within that yellow highlighted box is going to be one full cycle of my sine curve. So I use the fact that sine will start at 0, start on the sinusoidal axis, so I put that point there. And then it's going to end there as well. Then halfway between there, I'm going to be back at 0. So I have 3 points. Halfway between that interval is going to be 42.5. Is going to be my maximum value. And then halfway again between 65 and 110 is my minimum value. So I've got my sine curve. Now if I wanted to check a point, I could pull out a point. I'm saying 42.5, I need to get out of -2. So I could either plug that in my calculator and check, or work through it algebraically to verify that that point is in fact at -2.